Final rigid transformation today, which is rotation. So we talked about reflections, we've talked about translations. This is rotations or spinning. So our goal is to figure out what happens to a point when we spin it on the coordinate grid. So, yep, just spinning. So just checking out this image, anything you're noticing and wondering. One thing I notice is there's a center of the rotation, which for us is the origin. And let's just call this closest point, point A. It's always the same distance away from the origin. We're just spinning in a circle. So, same thing for this point on the triangle. It's just spinning around the origin this far away. So this is a rotation. This is how it looks. And you can go certain numbers of degrees. So let's look at how can we figure out a rule for a 90 degrees counterclockwise. So let's say I had the point 5, 5. Okay, it's negative 5, 5. Okay, so a sign changed. 4, 6 becomes 6, 4. 3, 7 becomes 7, 3. 2, 7 becomes 7, 2. So the x and y are switching. So on a rotation, we take whatever our coordinate is, x comma y, and we're going to change it to y comma x. We take the number that's the y, so that's the 7, and it becomes our x value when we do a rotation. The other thing that changes is the sign. Now the sign is a little tricky because here it's positive, positive, now it's negative. Here it's negative, positive, now it's negative and negative. And what's happening is it just depends on what quadrant you're in. So in quadrant 1, x is positive, y is positive, but in quadrant 2, x is negative, y is positive. So it just changes what quadrant you're in. That's how you could figure out the signs. But the big thing that's changing is the x and y, the coordinates just flip. So that's the big rule for today. We take the coordinate, we just change the y and the x, we flip them, and then you just double check your signs depending on what coordinate or quadrant you're in. So let's see if I could do a rotation. We're gonna do some notes on this. Let me go to the notes first. So rotations are just spinning a point a certain number of degrees around the center. Each point is the same distance from the center. Typically on the coordinate grid, we use the origin as the center, but you could use other points as the center. But normally we use the origin. So every 90 degrees moves each point one quadrant. So if I spin it 7 degrees, it's not very far, but once I get to 90, it moves from quadrant 2 to quadrant 3. Then if I go 180, now I moved 2 quadrants. If I go 270, 90 more degrees, I moved 1, 2, 3 quadrants. And then if I go 360, I'm back where I started. So every 90 degrees moves you a quadrant. So we typically do rotations in 90, 180, 270. No one really does 360 because it wouldn't move. So 90, 180, and 270 are the big numbers to remember for our rotations. Another thing to remember, you can spin 2 directions. This app is just letting me go counterclockwise, and counterclockwise is the positive direction. The reason it's the positive direction is because the quadrants go 1, 2, 3, 4, which is counterclockwise. That's just the way the quadrants are ordered, so this is the positive direction. If I spin the other way, it's going 1, 4, 3, 2. That's going against the quadrants. This is clockwise, and this is negative. So just in case, if this was a positive 90, that means we're spinning 90 degrees in the positive or the counterclockwise direction. So let's look at an example. If I had the points 1, -7, 1, -2, and 5, -2, and we want to rotate triangle ABC 90 degrees counterclockwise. So counterclockwise is this way. So I want to go 90 degrees, and I want to end up here in quadrant 1, because I'm going 1 quadrant, because it's 90 degrees, and I'm spinning this way. So I'm going to take my points, and I'm just going to switch 1, 7 becomes 7, 1. So I'm going to take 1, 7 and make it 7, 1. Now, they're both positive because I'm in quadrant 1. Right 7, up 1. Now let's look at B. 1, -2. Well, I'm going to just switch the coordinates. It's going to become 2, 1. They're both positive because I'm going to quadrant 1. So 2 comma 1, there's point B. And then point C is 5, negative 2. Again, switch the coordinates, 2 comma 5. So write 2 up 5. Let's see if this worked, switching the coordinates. So there's the spin. Yep, that's where it would spin to. So the rule to remember is you just switch the x and y, and then just check your signs based on the quadrant you're in. So give it a try. Oh, there is 180. So what happens with 180? On the next screen, I think I got this points. For 180, it's 1, 1. It's still 1, 1. 3, 3, 3, 3. 5, 2, 5, 2. The coordinates actually don't flip. And the reason is because if I go 90 degrees, I flip them. This would become 2 comma 5. And then to go 90 more degrees, we flip them again. So we go back to 5, 2. So for 180, you don't flip the coordinates because if you go 90, you flip them. If you go another 90, you flip them. And now you're back where you started. The only thing you do on 180 is you change the signs. Excuse me. All right, try that cool down. Which rotation would take L onto M? So how many degrees am I rotating to get L to M?